Hi, I'm Randy Bartholomew. I am the Integrated Solutions Consultant with Greenmark Equipment, and I started back in 2008. So we're going to talk about machine measurements today, why they're important and how to get accurate ones, and really the first thing we got to start with is the machine itself, okay? So the only thing that we really know GPS referenced wise is where the GPS receiver is, right? But we're trying to control things almost 30 foot behind us. So the measurements from that receiver back to that control point are very critical in getting accurate, dependable results, okay? So we always start with the machine, and when we start with the machine, we start at the GPS receiver. So the first measurement we need to take is from the GPS receiver to the center of that axle, okay? So this is going to be the first measurement in our GS3s or our Gen 4 displays. It will be that same measurement, okay? Once we have a measurement from the GPS receiver to the axle, we are going to go on to our second one. Now this one gets a little tricky. The second measurement is from the axle to the connection point. For this planer, we're using the 3-point arms, right? But you'll notice in your displays that it actually asks you what connection point you're going to use. Are you using a drawbar? Are you using the 3-point? It's very important because if we look back here and we look at the distance from this connection point at a 3-point up to the axles, it is a different distance than where the drawbar measures up to the axle, okay? Guys, we're talking inches here, but if we're really trying to get good, accurate measurements, it's very key that we get the right connection point and the right measurement. So, receiver to axle, axle to connection point. Whether we're in a GS3 or a Gen 4 display, this will all be very similar, okay? So we talked about measurements, right? So we need to enter some of those measurements within the displays themselves. So the first measurement we talked about was from the receiver to the axle. So within a Gen 4 display, we would click on Setup, we'll click on Tractor, we'll click on Tractor again, okay? And we're gonna edit this machine right here. And here are our GPS offsets, okay? So we'll click on that line there, and really we just need to find a reference, right? So line number 2 is the GPS inline distance, okay? So that is showing us from the receiver to the axle. That's that first measurement that we need to take. If you are in a GS3 display, that measurement is entered here. This measurement will be entered here where we change offsets, okay? Again, we look for that B measurement, and that B measurement is the inline distance from the non-steer axle to the GPS receiver. So that's the first measurement we need to take. The second measurement we took was from the axle to the connection point. Now on this tractor, we were hooking to the 3-point, right? So here we need to make sure that we click on connection offsets. We're going to select the rear 3-point. We'll select rear 3-point again. So we'll select the rear 3-point, and we're measuring from that axle to the connection point. And this is where we'll enter that value right there. Again, we'll click OK. If you are in a GS3 display, that is going to be entered in this C value right here. C is the inline distance from the non-steer axle to the connection point. Now I'm going to jump out of this screen right here because it is also very important that on the GS3 family we select that rear pivot 2-point as the connection type. Once we have the machine measured, then we move on to the implement, okay? So for the implement, our first measurement, it's a little bit different in a planer because we have this second pivot point within a planer, okay? So the first measurement that we do on a planer is from our connection point to our pivot pin, okay? It's very key. So we'll take that measure from that connection point to the pivot pin and enter that in the GS3 or Gen 4 display, okay? After that connection point measurement, the next one is from our pivot pin to the front of the implement, okay? So guys, the front of the implement isn't the most critical thing. Usually we just say it's just truly that, right? What is the front of the implement? But consistency is what's important, okay? And this is where we're gonna differ a little bit in the GS3s or the Gen 4 displays, okay? So for this measurement, if we were using a GS3, Scott's gonna line me up with there, and we would take that measurement all the way from that pivot pin back to the front of the frame, okay? The front of the implement, that we'd call it, okay? Continuing with how a GS3 would be measured, that next measurement is actually from the front of the frame to what the display is going to call the rear of the implement. And this is what trips everybody up, okay? Everybody looks at the rear of the implement and they say, well, it's the closing wheels, it's the back of the planer, that's the rear of the implement. It's really not. If you look at the verbiage in there, A plus B, okay, so some of these measurements we're going to show you in the display, equals the connection point or the control point when section control and documentation are in play. So the back of the planner truly isn't what we're looking for, because that's truly not the end of the implement on a planner. What we actually care about is that seed tube. That's what we're trying to control. Now you guys can't see it from in here, but within here, right, is your seed tube where we're dropping seed in the ground. That's what we're trying to turn on and off, and that's what we're trying to document, not what's happening back here, okay? So, connection point to the pivot pin to the front of the frame, and from the front of the frame, or the front of the implement, to what we're gonna call the rear on this, is going to be our section control points. Now, one thing we do need to watch, if we look along the back of this planner, all the rows are in line until we get to what? Right? These center 4 sections, these center 4 rows actually bump back, okay? There's nothing we can do about it, so we typically measure to the wings, because the wings are the majority of the planner, right? So we're gonna measure to where the majority of the planner is, and not to where the first or the last 4 center 4 sections are. Within the GS3s, we need to select the implement 1. Here's our 1775 NT. We'll click on change offsets. And that first measurement, that measurement A, is the inline distance from the front pivot point to the front of the implement. Within the GS3s, we do not account for that pivot pin. It is a straight up measurement from the connection point to the front of the implement. On a GS3 display, again, A was the connection point to the front of the implement. B is from the front of the implement to the rear of the implement. But what I want you to watch here is this little note that says A plus B equals documentation section control when in use, okay? We talked about the rear of the implement is not actually the rear of the implement as we would think, right? It's not the closing wheels, it's not the end of the planner. The rear of the implement is actually the seed tubes. So on this, we need to make sure we measure from the connection point to the front of the implement is A. From the front of the implement to the seed tubes is going to be our value for B. So that's for a GS3, okay? The new Gen 4 displays, we've tried to make things a little bit simpler, and we've cut out a couple of the measurements per se. In a Gen 4 display, everything stays the same up on the machine. Nothing has changed there, right? But it took 2 measurements in a GS3 display to get back to the work point, back to that section control point. With a Gen 4 display, and we'll show you where this is entered, there's the measurement, but here's what's different. In a Gen 4 display, they actually ask us for the working point. So that working point is going to be all the way up from where that pivot pin is at, where Scott is at, not to the front of the machine, but to itself where the seed tube is. This is the working point in a Gen 4 display. So we've kind of taken some of that confusion out of there, okay? So GS3s and Gen 4s within the implements do have a little bit of a measurement change, but machines themselves are very similar. Okay. The next measurements we took were for the planner. So for the planner, we'll select the planner there. We'll select the planner again. Okay. Our connection type is that 3-point. We do have this pivot offset. Again, this was the measurement from the hooks to that pivot pin on that planner. So we need to make sure that we tell it is pivoting, and we actually get a measurement in there, and let's say this is going to be just 1 foot for that measurement. So in the Gen 4 displays, we don't measure from the front connection point to the front of the implement. We simply measure from that pivot pin to the actual work point, okay? That work point on a planner is going to be that seed tube drop. So within here, we're gonna say that's 14 foot and 6 inches, okay? We'll click OK, and that will make sure our section control and our documentation is set up correctly on a Gen 4 display. It's very important that we get accurate measurements, right? We've got the activations, we've got the hardware, we've got RTK, that we're sub-inch accurate in GPS. Let's make sure that we're not losing that sub-inch accuracy because of poor measurements. So combines are very similar in the measurements, but they also are a little bit different. So we're gonna walk through those too and how these are measured out so we make sure that we get good documentation on that harvest data. So again, we start at the same point. Our GPS receiver really is the important key of where we're going to start from, okay? But in order to do this one, we actually have to go backwards and then forwards. So Scott, why don't you hold me right at that GPS receiver. Our first measurement on the machine of a combine is actually from the center of the GPS receiver backwards to the center of the axle of the machine, okay? So once we measure that, we're actually gonna flip spots here. And Scott's going to hold me back on that center axle. The second measurement on a combine is from the axle to our connection point, okay? Now it's a little bit weird because our connection point is right up against the back of the actual header itself, okay? So this is measurement 2, axle to connection point. When we get to measuring out the header, the first measurement for the header actually asks us from the connection point to the rear of the implement. Well, it's in the same spot, right? It's butted up right up against each other, so we always leave that value at 0, okay? But the next value that is key is from the back of the header down to the front of the gathering chains, okay? This is where we want to take that measurement so we can reference this off of that GPS receiver. And if you've ever ran a display in a combine before, you notice that there's a lag, okay, in what you see in the map versus what's caught up with the combine, and that's on purpose, right? But it has to do with these measurements. That lag is actually because it takes time for the crop to get through the machine, get threshed up the clean grain elevator and hit the mass flow sensor, okay? So there's a timing process there because we've also moved ahead, but there's also a distance process there that we need to make sure these measurements are right so that the yield map is placed in the right spot and is very accurate. So again, different, but also very similar in concept. So for the combine measurements, it's very similar to the tractor, but it is different in a couple ways. So in the Gen 4 displays, we're going to select our combine. We'll select it again here in this menu, and we'll click on GPS offsets. So the first measurement we needed to take was from the GPS receiver back to the axle, okay? So that is that number 2 value, that GPS inline distance is the receiver back to the axle. From there, we need to click on the header, and from the header measurements, we get the A measurement, which is our connection offset. Connection offset is truly from the axle to the connection point or the front of the feeder house. The other measurement we need to take is from the connection point to, let's say, the gathering chains, the front of that actual header. And that is measured in this 1 value right here, which refers back to our work point.